If you placed our sun where the center of Stephenson 218 is, you wouldn't be able to see it. Not because it would be hidden, not because it would be blocked, because our sun, 1.4 million kilometers wide, a ball of nuclear fire so enormous that 1.3 million Earths could fit inside it, would be a dust particle floating inside this thing's atmosphere, not orbiting it, not near it, inside it. The surface of Stephenson 218 would extend outward past Jupiter, past Saturn, all the way to a point in space that takes light, traveling at 300,000 kilometers per second. Nearly 2 full hours to reach from Earth. Everything you know as the solar system would fit inside this star with room to spare. And the terrifying part isn't just the size. The terrifying part is that we found it sitting in our own galaxy, 20,000 light years away, hiding in a cluster of already massive stars, as if the universe wanted us to miss it. If this is the kind of thing that makes you feel both insignificant and electrified at the same time, hit subscribe right now. Every week, we go somewhere the human mind was never built to go, and leave a like. It tells the universe someone was paying attention. Stephenson 2-18, catalog name, SD2-18. Also called RSGC 2-18, tucked inside a star cluster designated Stephenson 2 in the constellation Scutum. It was catalogued, filed, largely overlooked, until astronomers began measuring it properly. What they found broke the classification system. Stephenson 2-18 is a red supergiant. These are the largest category of stars by physical size. Not the most massive, not the most luminous, but the most volumetrically enormous objects in the known universe. Red supergiants are dying stars, bloated beyond comprehension as they exhaust their nuclear fuel, their outer layers expanding outward like a slow-motion explosion that takes millions of years to complete. And Stephenson 2-18 is the largest red supergiant we have ever measured. Its radius is approximately 2,150 times the radius of our sun. Put that number in human terms. If you drove a car at highway speed, 100 kilometers per hour, around the equator of our sun, that trip would take about 50 years, a full human lifetime. To drive around the equator of Stephenson 2-18 at that same speed would take 107,000 years. You would have started before Homo sapiens drew the first cave paintings. You would still be driving today, and you would have covered roughly 1% of the journey. For most of astronomical history, this star was invisible to us, not because it emits no light. Stephenson 2-18 shines with a luminosity of approximately 630,000 suns. On that scale alone, it is among the most luminous objects in the Milky Way. But it sits behind a curtain of gas and dust, so thick that visible light barely passes through. For centuries of stargazing, for every telescope pointed at that corner of Scutum, Stephenson 2-18 was hidden inside a fog we couldn't pierce. What changed was infrared astronomy. When we built instruments sensitive to infrared radiation, heat signatures that pass through dust clouds like radio waves pass through walls. A whole hidden universe began to emerge. The Stephenson 2-star cluster was catalogued in 1990 by astronomer Charles Bruce Stephenson, who identified the region as exceptionally rich in red supergiants. What he couldn't have known was what the largest member of that cluster actually was. Subsequent studies refined the measurements. Spectral analysis, distance calibrations, luminosity curves mapped against known stellar models. The numbers kept coming back impossibly large. Current estimates place its radius at between 2,000 and 2,150 solar radii. Some models push it even higher. The uncertainty itself is telling. This star is so far outside what our models expected, that pinning down its exact dimensions requires tools and methods that are still being refined. If the scale of that hit you, if you felt something shift in your chest reading that, hit subscribe. We go somewhere new like this every single week. Here is what 2,150 solar radii actually means in the geometry of our solar system. Place Stephenson 2 to 18 at the center of our solar system where our sun currently sits. Mercury, gone, swallowed instantly. Mercury orbits at 0.39 astronomicals from the sun. The surface of this star extends to roughly 10 astronauts. Venus, gone. Earth, gone, consumed inside the star's atmosphere, orbiting within its outer layers, incinerated. Mars, gone. The asteroid belt, gone. Jupiter, the gas giant so large that all the other planets could fit inside it, would be skimming just below the surface of Stephen 218, or possibly just barely outside it, depending on the measurement model you use. Saturn, with its rings stretching 282,000 kilometers from edge to edge, would be orbiting just outside the star's surface. Everything you have ever seen in photographs of the solar system, every mission, every probe, every planet, exists within the diameter of one star. Now consider, Stephenson 218 is not even the most massive star we know. It is not the hottest. It is not the youngest. It is simply the largest, a bloated, cooling, dying giant in the final chapters of its life, tens of millions of years old. Its core slowly collapsing under its own gravity, while its outer layers continue to expand. When it finally dies, it will likely produce a supernova, a detonation of energy so violent that for a brief period, it will outshine the entire galaxy it lives in. From 20,000 light-years away, that explosion will be visible from Earth in daylight. Not a twinkle, not a bright star. A second sun rising in the direction of Scutum, burning in our sky for weeks, and the core that remains. Depending on the final mass, it becomes a neutron star, an object the size of a city with the mass of our sun compressed inside it. Or, if massive enough, it collapses further, past every known physical threshold, into a black hole, the largest star we have ever found, swallowed, eventually, into the smallest and most extreme object the universe produces. The scale goes both ways. There are things about Stephenson 218 we still don't fully understand. The measurement of its size carries uncertainty because measuring the radius of a star this distant requires multiple overlapping methods. Parallax measurements, luminosity-temperature relationships, angular diameter calculations. And they don't always agree perfectly. Some papers have suggested its radius may be slightly smaller than 2,150 solar radii. Others suggest the upper bound could be higher. What we don't know is whether there are larger stars still hidden behind dust clouds in our galaxy and beyond. The Milky Way contains an estimated 100 to 400 billion stars. We have detailed measurements for a vanishingly small fraction of them. The infrared surveys are ongoing. The catalogs are still being built. There could be something out there larger than Stephenson 218 that we have not yet found. Something sitting in a corner of the galaxy we haven't looked at, with the right instruments in the right wavelength, at the right moment. The largest known object in the universe is a title that gets revised. It has happened before. It will happen again. Tell me in the comments. Does the scale of Stephenson 218 make you feel small, or does it make you feel something else entirely? I read every single one. We named it after the astronomer who first cataloged the cluster it lives in, Charles Stephenson. A human being who spent his career pointing instruments at the sky, recording what he found, adding to the inventory of the cosmos, one entry at a time. He didn't know he had found the largest known star in the galaxy. He just knew something interesting was there. That is what we do. We look, we measure, we name. And somewhere 20,000 light years from the paper where those coordinates were first written down, a star 2,150 timelines wider than our sun continues to expand, slowly, silently, indifferent to whether anyone noticed. Keep looking up.